Today's video will be talking about ultrasonics. So basically, under this topic, we'll be discussing about the properties of ultrasonics, the production of ultrasonics, their detection, and the different applications. So what are ultrasonics? These are nothing but sound waves having frequency beyond the human audible range. These are normal sound waves, except that their frequencies are such that we human beings, we can't hear them, we can't detect them. The audible range for human is 20 hertz to 20,000 hertz. This is the frequency. If the frequency of the sound waves are lesser than 20 hertz, we can't hear them, or technically we can say we can't detect them. Or if the frequencies are greater than 20,000 hertz, then also we can't detect them. Ultrasonics are these sound waves having frequencies greater than the human audible range, that is greater than 20,000 hertz. So this is the lower limit. Upper limit can be anything depending upon the frequency that can be produced by the different methods used to produce ultrasonic waves. And below 20 hertz, these sound waves are called infrasonics. So ultrasonics we come across in our daily lives, particularly when we go to the hospital for some diagnostics. Ultrasound, the procedure that is done, uses ultrasonic waves. So most of us we know about it. So here we'll be talking a bit in details about ultrasonics, what are their properties, how they are produced, and what are their uses, applications. So as I told you, because of their special properties which makes it different from the sound waves that we hear, ultrasonics are used in different fields. Human beings, we can't detect them, but some animals like dogs, bats, dolphins, whales, and some birds, they can sense ultrasonic waves. So here is the pictorial depiction of ultrasonic waves. Human hearing range 20 Hz to 20,000 Hz, 20 kilohertz. Below 20 Hz, infrasound or infrasonics. This is the human audible range. Beyond that, ultrasonics. So it can have a wide range of frequencies, as I told you. There is no upper limit. Upper limit is only limited by the apparatus which is used to produce the ultrasonic waves. And you can see here the wavelength, lesser frequency, wavelength is more, wavelength becomes less. So you can make out ultrasonics, they have very short wavelengths, as also they have very high frequencies. So what are some of the properties of ultrasonic waves? Let's look into it. They are highly energetic and high frequency sound waves. This is a very important property of ultrasonics which makes it very useful for different purposes. They are highly energetic. Sound waves, audible range of sound waves also do carry energy with them, but then ultrasonic waves, they carry huge amount of energy with them. Waves as such are nothing but disturbances which carries energy from one place to another, one location to another. Sound waves, when there is a bomb blast or during Diwali we burst the crackers, at times you can hear the window panes they rattle, or when a jet plane moves in the sky, you can hear because of the energy being carried by the sound waves. So ultrasonics, as I told you, these are sound waves having very high frequency, short wavelength, and hence also they carry huge amount of energy. So they have wavelength very short compared to the audible sound waves. And this is an important property. Because of the small wavelength, they suffer minimal diffraction as they pass through a medium, and they can travel long distances without substantial loss of energy. This makes ultrasonic waves very useful. So, for directional signaling, later when we talk about the properties of ultrasonic waves and their applications, we'll talk more about it. They can travel long distances without substantial loss of energy. They are mechanical waves and hence requires a material medium for propagation. This is very important. Ultrasonic waves are mechanical waves like the normal audible sound waves. Without a medium, they can't propagate. So they require a material medium for propagation, and they are mechanical waves. Of course, they travel with the speed of sound in a given medium. The velocity of ultrasonic waves increases with the increase of frequency of the waves. As I told you, the lower limit of the frequency of ultrasonic waves is 20,000 Hz, and upper limit can be anything. So as the frequency of the ultrasonic waves increases, the velocity of the ultrasonic waves also increase with the increase of the frequency of the waves. The ultrasonic waves, like audible sound waves or normal sound waves, they suffer from reflection, refraction, and absorption. And as because they carry huge amount of energy with them, when absorbed in a medium, ultrasonic waves, they produce heating effect in a medium. This is another property which makes ultrasonic waves very useful. Now, how are ultrasonic waves produced? Different methods are there, but basically we'll be discussing about two methods. One is or two generators. One is the piezoelectric generator and the other is the magnetostriction generator. So we'll go into it one by one. In this video, we'll be talking about the piezoelectric generator. So what is a piezoelectric generator? This is a generator of ultrasonics which uses the phenomenon of piezoelectricity exhibited by certain crystals. Or rather, in this, the inverse of piezoelectric effect is used. Inverse piezoelectric effect is used. What is meant by that we'll discuss. So piezoelectricity, or also called piezoelectric effect, is a phenomenon exhibited by certain crystals like quartz, tourmaline, etc. So if I ask you, have you used electricity in your daily life? You may get confused, but we do use, without knowing, knowingly or unknowingly, the gas lighters that we have, the lighters that we use, they use the phenomenon of piezoelectricity to generate a spark, which is used to light the gas in your kitchens. So it was discovered in the year 1880 by two French physicists, Perry and Paul Jacques Curie. They were brothers. It was discovered in the year 1880. What is it? It is the appearance of an electric potential across a pair of faces of a properly cut crystal when the opposite faces are subject to mechanical stress. So here two things are very important. Piezoelectricity is a phenomenon exhibited by certain crystals, as I told you. Now what is crystal or what is crystalline matter? Matter can be in different forms: solid, liquid, gas, and solids can be amorphous or crystalline. Crystalline solids, they have very regular structure, very regular pattern. If you look into two parts of a crystalline solid, you won't be able to make out the difference. The atoms are regularly arranged. So this gives rise to interesting properties of crystals. They are very regular in structure, and that apart, properly cut. Piezoelectricity will be exhibited by crystals which are properly cut. So crystals, later when we go into solid state physics, we'll learn more about it. They have specific properties. and as I told you, they have very regular structure. Depending on the structure of crystals, we can define different axes in a crystal. So two axes are there. One is called the electrical axis and one is called the mechanical axis. So a properly cut crystal means a crystal which is cut with respect to the axis of the crystal. So only if it is properly cut, it will exhibit the phenomenon of piezoelectricity. So technically, piezoelectricity is when the crystal undergoes mechanical stress along the mechanical axis of the crystal. An electrical potential difference is developed along the electrical axis of the crystal. So what it means is we have to cut the crystal in such a way that two pairs of faces are perpendicular to the mechanical axis of the crystal and two faces are perpendicular to the electrical axis of the crystal. And what these axes are? They are specific directions of the crystal based on its properties and its structure. We won't go too much into details of that here, but we need to know is that this axis can be defined in a crystal, and for it to exhibit piezoelectricity, the crystal should be cut in such a way that two faces are perpendicular to the electrical axis and two faces are perpendicular to the mechanical axis. So these are the two axes I am talking about. This is the mechanical axis and this is the electrical axis. The two faces, opposite faces, are cut perpendicular to the electrical axis and two along the mechanical axis. So what is piezoelectricity? Along the mechanical axis, if I apply mechanical pressure, the opposite faces perpendicular to the electrical axis will develop a potential difference. That is very interesting. For having a potential difference to drive a current in a circuit, we use batteries. So here we have a natural battery, you can see. Just by applying mechanical pressure, we generate electrical or we generate a potential difference. But this amount of potential difference developed is quite small. So you can see here we are applying mechanical pressure across this axis, then along the electrical axis a potential difference will be developed which can be detected. So what is the converse piezoelectric effect or the inverse piezoelectric effect? If we apply a potential difference across the electrical axis, then the mechanical axis faces perpendicular to the mechanical axis will develop a strain. That is the inverse piezoelectric effect. Piezoelectric effect is when I apply pressure, these two faces they will develop a potential difference. Other way around, if I apply a potential difference across these two faces perpendicular to the electrical axis, the mechanical faces perpendicular to the mechanical axis will develop a strain. So we have direct piezoelectric effect and we have the converse or the inverse piezoelectric effect. So in a piezoelectric generator, the inverse of piezoelectricity or inverse piezoelectric effect is used. Again, I am going to this figure. If I apply a potential difference across the faces perpendicular to the electrical axis, these two faces will develop a strain. Either it will expand or it will contract depending upon the direction of the applied potential difference. Now say if the potential difference is alternating, if instead of a direct potential difference, we are applying an alternating potential difference which keeps on changing with time, then what will happen? The faces perpendicular to the mechanical axis will start oscillating. So this is a simple principle or a phenomenon which makes possible the piezoelectric generator of ultrasonics. So for ultrasonic generation, the inverse or the converse piezoelectric effect is used as I told you. So if a voltage is applied across the two faces perpendicular to the electrical axis of the crystal, the other two faces develops a strain. If instead of a fixed voltage, an alternating voltage is applied, the crystal will set into vibrations along the mechanical axis. This I have already talked about. So if the frequency of the applied AC is tuned to be equal to the natural frequency of the crystal, the amplitude of oscillations becomes very high. Just neglect this off. So natural frequency means every system has its own natural frequency. Even we people have our own natural frequency. Someone who is very fast at doing things, he is naturally fast, and someone who is slow. Means every physical system, every person has his own natural frequency. Likewise, when set into vibrations, any natural system, material medium has its own natural frequency. So if the frequency of the applied AC is made equal to the natural frequency of the crystal, we call it resonance. The amplitude of oscillations becomes very high. Then, when the applied frequency is in the ultrasonic range, the crystal produces ultrasonic waves. We are talking about the frequency of the alternating voltage that we are applying to the two faces of the crystal. So this alternating voltage can be applied with an oscillator. We have devices which can produce alternating voltage, and we can tune the frequency. So frequency is made very high in the ultrasonic range, then the crystal vibrations that are produced, they produces ultrasonic waves. So let's look into the construction of a piezoelectric generator. So this part we don't need that much to understand presently. This is nothing but an oscillator. This is a transistor here. This is, we call it a tank circuit. This is a variable capacitance. And the outputs you can look here, these two from the secondary, the output. So we are interested in the output. So this is an electronic device. This whole part is an electronic device which generates an alternating voltage. We call it an oscillator. Using an oscillator, we can generate we can generate an alternating voltage. The frequency of the generated alternating voltage can be tuned using the variable capacitance. We can tune the frequency, we can increase it or decrease it. And different oscillators produces alternating voltage in different frequency ranges. Different depends upon different parameters, the transistor, etc., the variable capacitance, the inductors that are used. But anyway, point is, this oscillator will produce an alternating voltage. So this alternating voltage, the output of the oscillator, is connected to two metallic plates between which the properly cut crystal is kept. So that is what we are saying. If the frequency of the applied, AC, alternating voltage, is of the ultrasonic range, the crystal will set into vibrations and it will produce ultrasonic waves. So this is a simple structure of a piezoelectric generator of ultrasonics. The quartz crystal is placed between two metallic plates connected to the two output terminals of the oscillator. This whole part is the oscillator, and this is one output terminal and this is the other output terminal of the oscillator. The oscillator is tuned so that the frequency of the alternating potential produced is equal to the natural frequency of the quartz crystal, so that ultrasonic waves are produced. So what are the advantages and disadvantages of piezoelectric generator? With a piezoelectric generator, ultrasonic waves of frequencies up to 500 megahertz can be produced. So we can produce high frequency ultrasonic waves. High frequency means they will be more energetic, highly energetic, lesser wavelength, so they will suffer less of diffraction. They can travel longer distances without sufficient or without loss of energy. Output is very high and it is not affected by environmental changes like temperature and humidity. So when the piezoelectric generator is producing ultrasonic waves, external influences won't affect the quality of ultrasonic waves being produced. However, the cost of the device is very high, as the cost of natural piezoelectric crystals is very high. And another drawback, proper cutting. We are talking about properly cut. So proper cutting and shaping of a crystal is a difficult process. So these are two advantages. However, two disadvantages also we are discussing. So this is all about introduction to ultrasonics, and we have discussed the piezoelectric generator of ultrasonics in this video. So in the next upcoming video, we'll be talking about the magnetostriction generator of ultrasonics. Thank you.